In this video, we'll explore how to use the Conform modifier for different tasks, and dive into some of its more advanced options through a few practical examples. Let's start with a tire flattening effect. When the tire hits the ground, we want to stop it from intersecting the surface and instead have it bulge out around the contact point. This setup was originally shared by Greg Glazakos. First, we need to select the vertices that intersect with the ground and go underneath. We can use Volume Select Modifier for this. Set the stack selection level to Vertex, choose Mesh Object as the volume method, and pick the road. Next, add a Conform modifier and select the road as target. Set the method to Shrink Wrap and the direction to closest point. If you're working on a slower machine, you can try Vertex Normal instead. It's faster, but the result may not be as accurate. But a real tire wouldn't just stop. It would compress and bulge. You could use an Conform modifier here, but the soft selection from Volume Select is too narrow. Increasing it directly won't help. It'll start affecting vertices that haven't touched the ground yet, as you can see here. This is where the stack selection feature in Edit Poly comes in. It lets you pick up the selection from below in the stack and apply a fresh soft selection on top. Now, with the wider soft selection, the bulge looks better. This same feature is now available in Poly Select and Mesh Select, starting with 3ds Max 2025.2. If you just need to select subobjects, always use the Select modifier instead of the Edit modifier. It's lighter on performance. Thanks to the procedural power of the modifier stack, you can always go back and adjust the soft selection or scale amount to fine-tune the bulge exactly how you want. Now that everything looks good, let's finish it off by adding a Relax modifier to smooth out the shape around the bulge. In this video, we used the Conform modifier to flatten a tire realistically by projecting intersecting parts onto the ground and adding a nice bulge with soft selections. Next, I'll show you how to use the Conform modifier to line up high-res meshes and clean up the gaps around the edges. Here, I've got two dense meshes, each with over 500,000 vertices. I want to place this snow pile neatly onto this uneven embankment, and the volume method is perfect for that. First, apply a Conform modifier and pick the target object. Something looks off. Let's check the local axis. This is an imported model with a Y-up orientation, so instead of Z, we need to use the Y-axis for the projection. Now adjust the influence and fall-off values until you get the result you're after. You can also move and transform objects while conforming, and despite the heavy geometry, look at the performance. But wait, what's this gap around the edges? That's because the bottom of the model isn't perfectly flat, so some vertices don't fully conform. We can fix that by adding a second Conform modifier to shrink wrap just the edges. Thankfully, the first Conform modifier can output influence and fall-off as a soft selection. In the advanced rollout, open the Selection Output dropdown. By default, it's set to Existing, which just passes through any existing soft selection below. But we'll change it to Selection. This uses the influence and fall-off from the volume method. Now, add another Conform modifier. Set the method to Shrink Wrap, Direction to Axis, and choose the Y-axis. And pick the same target object. Nice, the gap around the perimeter is gone. Since we double processed the same area, you might notice a seam where the soft selection ends. You can go back and fine-tune the influence and fall-off, but if that's not enough, we can smooth it further using a data channel modifier. Since we need to smooth out the soft selection for the second Conform modifier, add a data channel modifier above the first Conform modifier, and press Add Operator button to open the same name dialog. Add a Vertex Input, Smooth, and Vertex Output operator. In Vertex Input, it should auto-select Vertex Selection, but if not, just pick it from the dropdown. In Smooth, set the iterations to 32 and amount to 1.0. Then, confirm that vertex output is also set to vertex selection. You can see the seam area blends more smoothly with the data channel modifier. Now, even though the Conform modifier is fast, stacking 2 of them plus a data channel on 500,000 vertices, that's still a heavy load. If you plan to use a lot of these, your scene might open slowly because everything has to recalculate when the file is loading. To address this issue, the Conform modifier includes a cache button. Pressing it stores the result inside the modifier, similar to collapsing the stack. This means you can safely turn off all the modifiers below, and the result will stay intact. The UI also grays out to prevent accidental changes. If you want to make edits again, you'll need to turn off the cache button. And that's it. The Conform modifier lets you align meshes perfectly in a procedural way, and it handles heavy geometry with ease. Next up, as we saw earlier, the Conform modifier can output different types of data as a selection channel, and one of those is mist. I've got a plane and a bunch of cylinders here. I selected all the cylinders as conform targets, then set the method to shrink wrap with the direction set to +Z. This way, the vertices project upward and conform to the top caps of the cylinders. If we switch to negative, they conform to the bottom caps, and if we set it to closest, they'll go to whichever cap is nearer, just like we covered in the previous video. Now let's switch it back to positive and change the selection output to mist. This flags any vertices that couldn't find a surface to conform to, but you won't see anything yet. To make it visible, add a mesh select. Then drop in a relax modifier, and you'll get some interesting results. I'm trying to conform this quad sphere to a scanned bread model to get clean, even topology. But with the vertex normal shrink wrap, you can see some parts get really stretched, like right here. So I added a relax modifier to smooth things out a bit. Then added another conform modifier on top. The vertices go a bit wild since a bunch of them end up inside the bread mesh. So let's switch the direction to closest, to make sure it finds the nearest surface. Go advanced rollout and change the selection output to ray distance. This is another cool output for the selection channel. It shows how far each vertex moved from its original spot to where it ended up after conforming. Since normalized selection is on, the values get scaled between 0 and 1. So the smallest movement is 0, and the biggest is 1. Basically, the blue vertices means that they are already pretty close to the target surface. Now I can just keep repeating the relax and conform steps using ray distance as a guide, excluding already conformed vertices. Each time I do it, the result gets a little more refined. Here's the before and after. This is what it looks like after 3 more rounds of relax and conform. The closest point method in the conform modifier can help bring back lost details after retopologizing a mesh. I found this CAD model from NASA's website, and it has really messy geometry. One last thing you can try to clean up geometry like this is convert the mesh to a volume, and then back into a mesh using OpenVDB. We can do this using the Boolean modifier. Apply the Boolean modifier and change the method to OpenVDB. The default voxel size is 1.0, which seems too big. Let's reduce it to 0.2. Now apply the retopology modifier and set the face count to 25,000, then hit compute. If you look closely, the edges are a little rough and some fine details are lost. The conform modifier with the closest point option can help recover some of that detail. Apply the conform modifier again, set the method to shrink wrap, and change the direction to closest point. Then pick the original mesh as the target. It's not perfect, but it helps. Just a heads up, the closest point method is the slowest among the conform methods. Only use it when absolutely necessary. In most cases, the vertex normal direction works just fine for shrink wrapping. And that wraps up some cool tricks with the conform modifier. It's a solid tool to have in your workflow. Thanks for watching.